Okay, good morning everyone. My name is Edvard and today I will be presenting my capstone, which is essentially an assault rifle magazine refilling system for the caliber of 7.62 by 39 for AK type of magazines. And if it was too complicated, it's basically a magazine refilling system for this type of assault rifles. So why is it needed? So there's this thing called trench warfare when soldiers jump into trenches and continuously shoot in the direction of the enemy, multiple rounds in a very quick succession, and they quickly run out of ammunition too. That ammunition needs to be replenished, the magazines need to be refilled, and that's why I came up with this idea. There were various ways of magazine refilling, for example by hand, which takes lots of time, effort, and also it is not protected from dirt, dust, lots of things can get into it, and you have to carry the ammunition or have it stored somewhere. The other one is by using a clip which can be attached to the magazine. It only loads 10 rounds at a time and also is not protected from anything. Also, you have to carry the clips on you or have them stored somewhere else too. Other loaders are like this one, which can only load one bullet at a time, also no bullet carrying or concealment. And this one, in which you have to line up all the bullets in a specific way and then push them into the magazine. In this case, the bullets can be put in any direction that you want, and by turning the handle they will be fed into the magazine, but only one bullet at a second. And the other one feeds 5 bullets into the magazine per push, but you have to really count it to not miscalculate. Also, it's not protected from dirt, dust, grease, water, and everything else. And that's why I came up with some system requirements for the system that I have built, which are allowing for bullet transportation and storage, providing protection against dirt and dust, fast refill of a magazine, easiness to operate so that the soldiers do not have to undergo heavy training to use the equipment, and scalability of the whole project. This is the iteration 1, or this one that you can see here. And did it work? Only one bullet fed into the magazine per push, but that's now how it ends. Not so fast, because we've come a really long way, and let's talk about it. There was an iteration 0, which was the initial idea from my thinking, from my drawings. I came up with this one, but there were various reasons why we didn't want to implement this one, so I came up with this iteration 1 that I've shown. And now we got the iteration 2, which is this one, and I will show it later. Okay, building the system. First of all, I did the sketches on paper, in SolidWorks. After that, I created the assembly in SolidWorks. After that, I printed the parts by using the 3D printers of our lab. Removed the supports, did the rifling so that 2 parts could be connected to each other by using the M10 hexagonal bolts that you can see here. And after that, I did the physical assembly and some testing, which I show later on. Okay, let me tell you what parts of the system I have. Here you can see the 2 walls that are basically enclosing the system. All of the working smaller parts are moving inside them. You can see spring tubes written with red here. Also there is the lid. The lid is this part. It encloses the whole system, protects it from dirt, dust, grease, and also provides a surface for the springs to operate. The receiver, which is this part, is the place where you connect the assault rifle magazine to. The pusher, this part, it basically pushes the bullets into the magazine and extracts a section when it is pulled back. The section is this part, which is put between each row of bullets, and the reason for it is to separate the rows of bullets from each other so that there is no confusion, they do not get mixed up and everything else. The upper section, this one, is the last section that you put into the system. The springs are pushing on these round parts that you can see and keeping the bullets at the level which is needed for the whole system to operate. Let's talk about some constraints and issues that occurred. For example, the calculated and ordered springs were not the same. I did lots of calculations, the inner outer diameter of the springs, the thickness that the wire should have, working and passive coils, etc., etc. I ordered the springs. They were 1 millimeter bigger in radius, which changes a lot, so they could not exert as much force as needed. Also, the offsets weren't enough because I gave 0.15 to 0.2 millimeter offset for parts so they do not get stuck, but because it was 3D printed, there were some issues connected with it. There is also the art of 3D printing, which I had not mastered at the time. So applying little glue to the 3D printer's build plate or putting something on its bigger surface would result in the part being bent, curved, warped, which also had its effect. Some parts were too thin and could easily break if a wrong force angle was applied to them. Also, curved parts didn't allow for proper assembly and testing. Extra space, which at the time was between parts, did not allow for the bullets to go into the magazine, but rather they went into those openings. And the 3D printer's dimensions didn't allow for full part printing, as you can see here. Each part is divided into 2-3 parts so that they were printable. But whenever I printed wrong parts or when they didn't have the dimensions that I need, I didn't give up on them because these three can really work magic. I'm pretty sure you are well acquainted with these tools. They helped me out a lot. Sometimes there were cases when I needed tools that did not exist. And that's when I created my own. For example, the support removal stick. It's a simple hook like this, which helped me to get into those little tight spaces and remove all the supports that were not needed. The sanding table, as I called it, which is sanding paper attached to a board, that helped me to do the job easily. And the sanding cylinder, so I had the spring tubes, which were already there, but they were of a wrong size, so I attached the sanding paper to this tube, and it allowed me to enlarge the tubes so that the springs would fit. And the sanding tool, as I call it, it also helped me out a lot for the support removal and other parts editing. Now let's talk about the iteration 2. First of all, why did I do the iteration 2? To increase the offsets and have smoother working parts, first of all, to adjust the spring tubes to the size of the ordered springs, to help the upper section withstand the weight of 300 bullets in 10 sections. So this whole system can store and load 300 bullets. This upper section had to withstand that weight, and we were not sure if it would. After some tests, some of these round parts broke, and I understood that it should not only be thickened but also widened to be able to withstand that force. To make the bullets perfectly parallel to each other, because if you use sections like this, each row of bullets will have an 8.4 degree angle with the previous row, and that's not what we want because the 10th section would be nearly perpendicular to the first one. So I created this one, which already has a shape that will help the bullets to fit perfectly. Whole aim was to make the system's loading process easier and faster. Let me show you here. So this is the wall, and these are the holes, which allow for easier bullet loading into the system. And less space in fixed parts, so that the bullets will actually be fed into the magazine, not into the wrong parts of the system. And also, here I mastered the art of 3D printing, and I was able to print the parts in a way that they were nearly not curved and warped. There were some limitations though. So which parts have changed in shape? We got acquainted with the parts. Now let's see that the back wall has turned into two parts. This part allows for easier bullet loading into it, and this cover allows for protection against dirt, dust, grease and water. And it is showing the caliber that should be fed into the system so that there are no confusions. And the middle section, as I've already told, has changed. The upper section has changed. The pusher has changed. Now it has a handle which makes the loading, the extraction of sections, the pushing of the bullets into the magazine much easier and more convenient. Also, the receiver is now identical to that of the assault rifles, so that the soldiers do not have to undergo any extra training. It is like this with the button and the spring, so they can simply take the magazine, connect it, and it sticks like that. And they take it out the same way as it is for the assault rifles. Okay, so this is the full assembly of my second iteration. And the question is, does it work now? Yes, it does. It can load up to 10 bullets into the mag per each push. And I have conducted some tests. Let's see and talk about them. So we had a concern that the pusher will not be able to exert enough force to push the last bullet into the magazine. Because the more bullets you put into the magazine, the more force the spring has counteracting the force of the pusher. And so I have tried putting one bullet at a time, feeding one bullet at a time into the magazine, and it worked just fine. There were no errors at all. The other test on the right part, as you can see, is loading 5 bullets at a time. So I wanted to understand, okay, it's no problem to load 1 bullet at a time. Can we do it with 5 bullets? No problem occurred either at that part. And then in the middle part, you can see the video of me trying to load 10 bullets at a time. This one is the iteration 2 video. And here I put in the magazine, I align it, and no problems occurred with loading either. I will now show how many bullets got loaded into the system when I take out the magazine. So it is loaded 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 bullets were perfectly fit into the magazine. They were not misaligned, they were not in the wrong direction, everything was just fine. Let's now talk about the limitations. Of course, the limitation of time, I was given 1 year, and I had to do everything that I could in that time. The resources, because if I had more resources, I could buy more springs. If those ones didn't work out, I could take the other ones, experiment with those, which I couldn't at the moment. Materials, so mostly everything here is 3D printed using generic PLA, which is a limitation itself, because the hardness, the the stiffness of the parts was not industrial or military grade. And of course the equipment, the 3D printers, which did not allow for full part printing, and that resulted in some issues itself, which I solved as much as I could. Let's talk about future work. So in the future, the system can be rebuilt from stainless steel so that it is not subject to corrosion, and all the parts are working smoother and in full parts, so that each part does not have to be divided into smaller ones. So here you saw the holes, which made the loading of bullets easier, but I also mentioned that sections are going to be put after each row of bullets. And on the back part, there is no opening, so an opening can be done for those to be inserted too. The wall covers can be made transparent, and the amount of bullets left can be displayed, shown on the wall, so that the user knows exactly how many bullets are left in the system. The drawings on the walls can be made so that people do not confuse and put bullets in the wrong direction. You know, it should be put like this. I don't want anyone to be putting it like this, so that could be changed. Scaling the system. Now it can hold up to 300 bullets, no problem. We can scale it up to 600, 900, and even 1200. I think 1500 would be too much for the tall guys. I don't know, I don't think that is really military grade. The system can be able to fit multiple caliber types. This one is for 7.62x39. It has the biggest openings, and we can make it for 5.45x39, 5.56x45 without any problems. The only thing that should be changed are the middle section, upper section, and the receiver. All the big main working parts can stay the same. Also, I would really like to smoothen out these edges, because while working with it I had lots of cuts and bruises, and we do not want our soldiers to have those, especially during a battle. And also a component can be added in the system, which will allow for the headquarters to track the amount of ammunition that is left in it. So that when a middle section goes up, they receive a signal that now this position does not have 300 bullets, but rather 270, 240, so that they can refill the position with new ammunition at the correct time. Okay, I want to thank you all for listening. Thank you, Ms. Satanik, for opening this type of military capstone projects for engineering. I want to thank you, Arman, for being with me during the whole process, for guiding me through it. And I want to thank all my engineering peers from ES2, juniors, sophomores, seniors, and alumni, which helped me out throughout the whole process with brainstorming, with printing, with fixing parts, with support removal, and assembly. Thank you so much, and these are my references.
Job. Very well
Thank
done.
you. Thank you.
Very well done. Have you calculated the weight of your system when fully loaded?
Yes, without these parts, the bolts, it's 11 kilograms. With those, it's 12 kilograms. But the system is stationary. It should be put into the trench itself and not moved all the time. So people get to it, get closer to it, feel their system, feel their magazine, and go back to their position. So it does not have to be carried all the time.
Well, in general, you have to have an operator for that one, but still, it's a very valid design. How easy it is to operate when there is no light?
When there is no light,
Yes.
you mean to load the magazine or to load the system?
To load the magazines.
There is no problem because you simply put the magazine here, you pull the pusher and you push it forward, and that's it. You do not have to see something exactly. You just can feel this part. It feels like the place where you should insert the magazine, then you feel it and you take it out.
Okay, and is there any chance that the user will not feel when the magazine is fully refilled?
No, because
Or
it
you
is.
just need the 3 pushes and that's done.
No, it's not at this time. Yes, because now it does not load 30 bullets at a time. But when this pusher comes to this position, then it's over. You know that the magazine is full. Now, because it loads only 10 rounds, yes, you have to do 1, 2, 3. But after the third one, you will not be able to push bullets into it anymore, and the magazine will not be damaged either. I've done some tests with that too, and no misalignment of bullets occurs even at that time.
And what will be the projected cost of this to produce one military grade, from stainless steel or whatever? Have you calculated the cost of this?
I have not calculated how much would it cost to produce from stainless steel, because it's yet out of the scope of the project, because I have yet improvements to do here, and when all the improvements are done, I'm gonna move on to injection molding, CNC, and to making it from stainless steel.
So a banana clip takes 30, and you put the banana clip on one side, and each row has 30 bullets,
Yep.
and you actually load 3 times currently, 10 at a time, to fill the banana clip. So basically, there's a spring inside the banana clip, and the force is equal to kx. So as you load, the first one goes easier, second one goes a little harder, third one goes a little harder. Have you actually loaded 30 bullets to see if you get any misalignments on the last 20?
Yep.
Last 10?
I've done, let me show you here. I've done tests, and this one, when I was loading 1 bullet at a time, I have loaded 30 bullets into the system. Yes, I have been putting 1 bullet at a time, but there were no mistakes. There were no misalignments, there were no errors. The bullets fit perfectly, all 30 of them, and it was perfectly usable. In fact, sometimes...
You haven't done 3 groups of 10, have you? Meaning
I have. I don't have the video here, but it works the same.
You had no misalignments.
Yeah, no misalignments. Even more, when sometimes you load it by hand, you should bump it so that the bullets go down. In this case, you do not have to do it. They are already in the correct position. You do not have to do it at all.
How do you refill the system? Can you show us?
I can show you
Loading
here.
the system.
Yeah. So you take out this cover, you open this part as much as needed, you can take the door off, you put the bullets in from here. After you put 1 row of bullets, you put a section like this from above. Then after that, you put bullets in the second row. It is visible how many bullets there are, so one cannot miss. And like that to the top, then you put the upper section so that the springs can work. After that, in my case, I use 2 springs for each tube. You put one spring at the top, one spring connector in my case, and another spring, and so on. Then you take this, you close the system, you fix it with bolts. From here, these are M10 hexagonal bolts. You close the system and it is ready for use. As simple
So
as that.
essentially it's a one-time use during the battle because to refill you have to be in a perfect state of mind. No one should be shooting at you, etc. But still very, very impressive design.
Thank you.
And did you discuss all of this with the military experts?
I have, while I was studying in Vazgen Sargsyan Military Academy, I had a second colonel which I told this about. He guided me a bit. He said that, these problems can occur, you should take this into account. And I did. And when I was talking to other officers, they were also impressed. And they were saying that this can really make a difference during the battle.
Which kind of battle and what kind of troops?
So mostly during trench warfare, because during trench warfare you do not leave your position, you do not move a lot, you're just here, you can go 5 meters there, 5 meters to the left, but mostly you are in the same position. Mostly by infantry, which is protecting the trenches in modern times. It is mainly being used by them, will be.
But compared to 20 empty magazines, which you can have extra at position, how do you compare the system to this 20 cost-wise? 20 extra magazines, which normally you would load if you have 600 capacity, with the cost of the system that you have presented. Have you done such considerations?
I have not, but if we are talking about this one, printed with a 3D printer, it is even cheaper. It is much cheaper because the army grade magazine, this one is for AK-103, not for AKM. It costs 25 on the market. It's 20k drams for the military. So if we have 300 bullets here, then we need 10 magazines. Then it will be 200,000 drams, and this whole system does not cost that much.
Think about the cost of the production of the magazine. Why you are considering buying it, not producing it instead of this device?
Because this device can also protect the bullets inside it from dust, grease, dirt, water, corrosion, and everything else. The bullets here are aligned, the whole thing is closed, nothing can get in here. Mostly nothing.
Larger, basically, right? It can be larger.
It can be scaled up, yes. So it's gonna be put on ground, and this is not easy to operate on ground. So if it is 600, 900, it will be much easier to operate, and it will be able to fill multiple magazines.
To that point, if during the filling of individual, you're assuming that there is a protocol, and as Alec also said, it's done in a perfect state of mind and no bullet is missed. Let's say one bullet is missed. Have you taken into account that there's just an empty space and you accidentally operate it? Does that result in a full decommissioning of the device?
Not at all, not at all. I wouldn't say that it's perfect, because when pushing you can feel that one bullet had to go like this, it goes like this for a second. But you push it, you look into the magazine, it's perfectly fine, nothing happens.
And have you tested those malfunctions?
I have done one bullet, then one space, one bullet, then one space, it was okay.
I'm just trying to think of like in an actual situation, would you want to carry this with you? Or would you want to have one guy in charge of this? Or is this being done in a truck and there's one soldier just filling these up really quick? Because if you're in a battle, you're nervous, you know how it is. You're really nervous. Your thing doesn't work, then you push it too much, you push it too little, you say, okay, I have 5 in here. And that's probably good enough. The next guy comes in, it's like he doesn't know what to do. I'm not saying anything. This is one of these, like, necessity is the mother of invention kind of projects. I'm just trying to think in a trench. would you really want to have these, or would you want to have someone in charge of doing that? So he could even throw them to you. It may be even better. I don't know. I mean, because this is pretty heavy too. When this is filled, that's not light. You need a pretty heavy guy to. I'm wondering the philosophy of where it's going to be used and how it's going to be used. I think it's great, but where and how? I'm just sort of, unless you guys discuss this at the academy, how this really would be used. Any thoughts on that?
I have. It is heavy, but it's not gonna be moved around frequently. It's gonna be brought and put into the trench, and people are just gonna come up, put the magazine from here, pull and push, and that's it. They do not have to carry it with them all the time. The loading of the whole system initially, before bringing it into the trench, can be done in the, we call it Hasa Bahest. Yeah. So they do the loading there, they bring it into the trench, and then it is done. I think the mechanism is pretty simple, and no errors can occur with loading. So I don't think that someone will not understand how to do it or how much to push it. You just push until there is no more space to go. It's that easy. I don't think that any problems should occur with that, really.
You know, if you put this at the bottom of the trench, it's really dirty, you know?
Yeah, it is. It really is. But as I've said, we can scale it up because this one is really low. We're not gonna operate it like this. We'll scale it up. We'll put it at a higher level, and it is also protected from dirt, dust, grease. So no problems should really occur in that case either.
I'm going to paint it green. No.
Usage-wise,
think-
there are some questions, but as a mechanical design, as a mechanical engineer, it worked brilliant.
Thank you.
I think everyone is invited to collaborate and make this happen.
I would be glad if I could continue working on this project and
What's the weight loaded? What's the weight of the unit loaded?
to load the magazine or the system.
The whole unit when it's loaded, how much is the weight?
How much is the weight? Without these bolts, it will be 11 kilograms. With, it's 12 kilograms for now.
With the bullet.
With the bullets, yes.
So one person can easily carry it.
Yeah, I mean, you should not really carry it, but one person can, of course.
I'm very sorry, but I have to have this discussion at this point because, yeah, we have to move forward. Thank you very much.
Thank you so much.